Hello, in this video we'll be doing more of the measures of location or position. So Boxplot is another one. When data set contains a small number of values, a box plot is used to graphically represent the data set. So the plot involves basically we call them 5 number summary values. 5 number because there are 5 of them. Very important number. Okay. So, and the box plot shows us whether the distribution is normally distributed or whether it is skewed. It shows this very easily, as we will see. So the 5 numbers we need to construct the box plot are the minimum number, the lowest number in the data set, and the highest number in the data set, and then the lower hinge, called the lower hinge or first quartile, lower quartile, which is the median of all the values in the lower half of the data set. So if we divide the data set into equal half, the lower half, we find the median of the lower half. If we find the median of the upper half, that gives us the upper hinge, which is third quartile. Okay, the median is second quartile, which is the middle number, as we already know. So let's look at an example right away. Construct a box plot for the number of farms in 6 counties in western Pennsylvania. Comment on the shape of the distribution. Then B, find the interquartile range. Okay, we are given 1, 2, 3, 4, 5, 6. There are 6 in these 6 counties, 6 numbers. Wow, a lot of farms in those counties. So first of all, again, arrange the data in order from least to greatest. Okay, I've done that here. And then we find all our 5 number summaries. Okay, let's do that. Okay, let's then define the minimum. What is the minimum of the number? Once you arrange it in order from least to greatest, you see that the minimum is 338. So write that out, 338. And the greatest, right away, we can just write it. The maximum is 1369. Okay. And then the lower hinge, we divide this into equal half. So there's 6, 1, 2, 3, 1, 2, 3. So from here, it's going to be kind of the midway. So there are 3 numbers in the lower half and 3 numbers in the upper half. We find the median of these 3 numbers. The median is the middle number. Since they are odd, the middle number is the median right there, looking at us. So we just write it 6, 3, 3. And then the median of the upper half, 1, 1, 3. So that's 1, 1, 3, 9. And then we find the median of the whole number, the quartile 2, the middle number. Okay, so since there are 6 numbers, we have to take the average of the 2 numbers in the middle. So we do 5, 4, 7 plus 7, 6, 7, and then we divide them by 2, just like the midpoint, okay? Midpoint of those 2 numbers. So if we do that, if we add these, we're going to get 1, 5, 1, 4. Then we divide by 2, we get 7, 5, 7, okay? So that's 7, 5, 7 is the median, which is the middle quartile. Already, now let us graph. After we found these 5, we just put these on a number line. We put them on a number line. So I've created a number line here. Okay, let's move a little bit so we can see on each of these numbers. Okay, I can maybe erase this since we have already found this, so that way we have our space for this. Okay, good. So again, we found this to be 7, 5, 7. All right, so how do we locate each of these numbers? The minimum, 3, 7. Again, when you create this another thing, create your number line, the intervals have to be the same. Since my lowest number is 338, maybe I start with a number closest below 8. So I started with 300. But then I have to make my interval the same. So I chose to do this 150. So if you subtract 450 minus 300, you get 150. 600 minus 450, 150. 750 minus 600, 150. So the space between each of these points are 150. So otherwise it will not show the correct distribution of the graph. Okay, so in between these two numbers, we find 338. Okay, if we find 338, so 338 should be closer to 300. So just let's do estimation. So maybe you put a point somewhere there. And then since it's not a number, since the number does not show on the graph, we just write it out. We write that 338. All right, next we find our lower quartile, which is 633. 633 will be between 600 and 750. And it will be closer to 600 than it will be to. So somewhere there, again, we make a point, an estimation. And this is going to be our lower quartile. So we kind of, where the box is going to start. So we just make a point. And then a line. So this is 633. All right, middle number is 757. 757, very close to this, but not quite on it. So somewhere there. Okay, and then that's our median, 757. All right, this is a box. Okay, one more for the quartile. 1139, it's 1139. So it's between 105 and 120. 1050 and 1200. So it's closer to here somewhere. Not quite in the middle, so it's gonna be somewhere there. Okay. Okay, we connect those. That's our box. Okay, the box is the lower quartile, middle quartile, which is the median, and upper quartile. Those three make up the box. And then the line we call whisker. Start from this point and just make a line there. That's the whisker. And then we do the same for up, the greatest number, which is 1369. 1369 should be between these two. So somewhere there. 1369. Okay, again, we make a whisker, draw a line to connect it there. So that's our 5 points. 1, 2, 3, 4, 5. So again, since the number is not on the line, we write it on top there to identify exactly what number that is. And the lower one, this one is 1139. Okay, that's our box and whisker plot. And the 5 summary values. The 5 summary values are shown. So we can how we can comment or information this will give us. If we look at the median, supposed to be the middle number. If this line, the median is right in the middle of this box, because the box is made up of 50% of the whole data. The whisker is made up of 50% of the whole data. So because remember the quartile divides the data set into 4 equal parts. So from the least number to the first quartile is 25%. From the first quartile to the median is 25%. From the median to the upper quartile is 25%, and from the upper quartile to the greatest number is 25%. So, but you see, looking at the graph, the shape is not equal. They are not equal. So that means it is skewed. So if this point is right in the middle of this box, then it is normally distributed. But here, the median is shifted to the left of the center of the box. So that means there is more dispersion here. So it is skewed to the right. It is skewed to the right. If the median was more on the left side of the box, then we say it is skewed to the left. So this box is skewed to the right. So that's what we can say about it. Okay. And here, I just gave some of the things. Check the median. If the median is near the center of the box, the distribution is approximately symmetric. If it is false to the left, the box is positively skewed. Positively means it is skewed to the right. Right, we see positive numbers in the right side, on the right side of the number line, okay? And then if it is false, if the median falls to the right, that means there are more dispersion on the left, so it is negatively skewed in the left. So another one we could look, other things we could look at is the line. Supposing the graph is symmetrical, and yet the line, one of the line is longer, like what the right one is longer. So that means there is maybe an outlier, okay, something like that. Okay, another thing we want to find is the interquartile range is very simple. Just like range is greatest number minus least number, interquartile range means the upper quartile minus lower quartile. So we find our upper quartile, which we already found, is 1139 minus the lower quartile, okay, and then we get 506. Okay, that is it.